mod of z equal to 0. So in this question you can clearly know that z is nothing but a complex number. So how to solve this question? You need to know the basic concept of complex number. So let me assume that z is a complex number which has the real part as x and the imaginary part as y, right? So the question is asking me that z square plus mod of z equal to 0. So what are the number of distinct solutions, right? So if I square this, you're going to get x square minus y square plus 2xy I plus under root x square plus y square equal to 0, right? Okay, you have your square, right? So if I just minimize this part, perfect. Okay, so now what you're going to do, you're going to relate the imaginary part with the imaginary part and the real part with the real part respectively. So clearly you can see that imaginary part is going to give you 2xy equal to 0, which will mean that either x is equal to 0 or you have a y equal to 0. Basically this does not mean that you have two solutions. Okay, now you need to check the validity of both these equations individually. So let me just take a case where let's say that x is equal to 0. Okay, now this can be considered as case 1, x equal to 0, and this can be considered as case 1. So when you're putting x is equal to 0, that means that from this equation, if I copy this equation, you're going to, because it is going to be helpful in all the parts, right? So I am going to put x is equal to 0, so I'm going to get minus y square plus under root x square plus y square equal to 0. I mean, you're going to replace 0 over here also. This is the case. So you're going to get y square is equal to mod of y, right? So that means either you can have y equal to 0, okay, or you can have y equal to positive 1, okay. Now in the next case, now obviously you will think that y cannot be y negative, so y can also be negative. That's not a very big deal. So you can also put y is equal to minus 1. Now for the next case where you have y equal to 0, that is the case 2. So you're going to have x square is equal to minus under root x square. That is going to give you x square is equal to minus mod of x. Now we all know that mod is always going to give you a positive quantity. So negating the mod is always going to give you a negative quantity, and x square is going to be is not going to be negative, because the problem is that we have taken x and y as real quantities, right? Although x and y are involved in a complex quantity, but x and y individually are real quantities. So this case is going to give me no solution, right? And what about this, the case 1? Case 1 is going to give me, for x is equal to 0, you're either having y equal to 0 as a case, and y equal to plus 1 and minus 1. So basically you have three cases, that is 0 comma 0. I'm not writing it over here because, so the answer is you're either having 0 comma 0 or 0 comma minus 1 or 0 comma 1. Now if you have any doubt, you can actually check it in the real equation. You have z square plus mod of z is equal to 0. Now let's consider a case where you're having, okay, sorry, I'm so sorry. Yes, that's right. Where you have this case as complex number is just I. For this case is I. For this case it's minus I. And obviously 0 comma 0 is satisfying the equation always. As you can see, putting 0 over here and 0 over here is going to give me the answer. So there's no problem with 0 comma 0, but I have the problem with the set of 0 comma minus 1. So if you put minus I over here, so that's going to give you minus 1, and mod of I is going to give you plus 1, that's going to be 0. Similarly for this one, that's I, so I square plus 1, that's going to give you 0. So the total number of solution is basically 3. Thank you.